we are going to take a look at further of object-oriented programming. In the previous module, we take a look at the class and object. So for object-oriented programming, the three major features including encapsulation, inheritance, and polymorphism. Encapsulation, when we discuss object and class, we introduce the concept of encapsulation. So we encapsulate related information of object into a class. And we also introduce access modifiers such as private to help hide implementation details. Here, we want to continue and look at inheritance. The purpose of inheritance is basically allows the developer to reuse proven and debugged software. In other words, you don't duplicate the same code. And when you duplicate code, of course, you make your code longer. But also another thing is that when you want to debug, you have to fix in multiple places, and it can become a problem. So a derived class is normally a specialized group of base class. So a derived class has a direct base class and also have indirect base class. So in other words, you are building an inheritance hierarchy. And the whole .NET class library, every class actually inherited from the system.object class. When we talk about inheritance, you need to be aware of this is a relationship. So in other words, it implies that the specialized class, in other words, the derived class, has all the characteristics of the base class. So in other words, for example, I have a base class of person and derived class of student. The student is a person. So specialized is a generalized. So base class and derived class, many times you hear other terms such as superclass and subclass. So superclass is the base class and the subclass is the derived class. So for example, in this picture, the base class is this community member, and derived from the community member, you have employee class, student class, and alumni. Then from the employee, we can continue inheritance. Faculty and staff are inherited from employee. So for faculty, the direct base class is this employee class. The indirect base class is this community member class. When you inherit from a base class, you basically inherit all the information, fields, property, method from the base class without having to rewrite them. So you can use those. Of course, you probably want to make changes. So we are going to introduce some of the method that you can make changes of the existing information of the base class. So back to the is a relationship. So objects of all classes that extend to a common base class can be treated as objects of that base class. Meaning, for example, employee is a community member, student is a community member, and alumni is a community member. However, the community member is not necessarily an employee, because it could be a student, it could be many other possibilities. So what we're saying here is the object of the base class of derived class is a base class. However, a base class object, you cannot treat it as a derived class object. We are going to introduce some more information so that you can, in fact, override or redefine the base class information. In terms of syntax, so assume that you have a base class automobile, and this is a standard class definition. Start with a keyword class and the name of the class. Then for the inheritance, for example, I have a car class that is inherited from automobile class. I use this notation, colon. So before the colon, this is the car class, that's the derived class, and the base class is an automobile. So for example, automobile has some of the properties such as make, year, model, mileage, and price. And then you have 3 different inherited class, derived class, cars, pickup, and SUV. So all the base class information, as long as they are accessible, they are inherited by the derived class. However, you could add new information. You can modify the existing information of the base class in the derived class, but also you can add new information. For example, I could add, for example, for cars, add a new property that is the number of doors, which is not, which does not exist in the automobile class. Similarly, you can add other information for pickup and SUVs. So here's the code example. So for the automobile class, we have some private fields, and then we expose those private fields through the property. So property, public property, and make is the corresponding property of the underscore make. So this is a standard automobile base class. Then we have a car class that is a derived class. So notice the syntax, colon, car is inherited from automobile, and I do not have to rewrite any of the existing code. They are automatically inherited, but I could add, for example, a new field that is doors, and then we are going to use add another property, doors, to basically expose the field. And also we can add constructors. So when we, for example, instantiating object for the car class, my car, this new car, I'm basically invoke this constructor, then automatically my car has the property of make, model, mileage, and price, even though I did not write them in the derived class. They are all inherited from the base class, and they are all public, so they are exposed. We are going to take a look at different access modifier, not only private and public, when we do example. But as you see here, the public members, public is the most open access modifier, meaning that you can access this member outside of the class, outside automobile class. Okay, so next, let's take a look at the constructors. So base class and derived class constructors. I'm going to use the example for this. Here is the example on the Blackboard. This is, again, a management we used previously for the when we introduced class and object. This is a slightly different version of it. So the starting point project is already uploaded, so you can download it and then follow along. Let's take a quick look at what this simple project has. We have a demo view, and over there we have a text block that for displaying informations. So text block with a name of display. Then we have a person class. A person class is a fairly simple class, has some of the private field, name and age. Then we have two constructors, so this is constructor overload. And then we have some properties, and that's it. We have an employee class, and this employee class is inherited from person class. Then we have a manager class. This one actually probably is not in the project uploaded. This is just a placeholder you can add, right? So go to here, add a class, add the manager class, you will get this template. So that's what we have to work with for now. There's not much to say about the base class. So this is a very simple class. So we'll start with the employee class. So starting from the constructor, as you can see, the constructor is employee, and it has some red wiggly line underneath the constructor name. And it says person does not contain a constructor that takes 0 argument. What does this really mean? So so for employee, the derived class, if we don't write anything after this constructor, we are basically implying that it's inheriting a base class constructor that takes 0 parameter, in other words, the default constructor. What the complaint was that this constructor does not exist in the base class. So if you come back to the person class, you see that we have 2 person class constructors. One takes 1 parameter, the other takes 3 parameters. So once you write constructor with parameter, your default constructor that takes 0 parameter is not going to be automatically provided by the compiler anymore. So if you really need that, you have to explicitly write that constructor. So the syntax for constructors in the inherited derived class is that you are going to use the colon, then base as a keyword, then evoke the base class constructors. So for example, we have a constructor that takes name, gender, and age. Okay, so name, gender, age. So this is one of the constructor that is in the base class person class. And then we have 4 this time different parameters. So we are going to basically add another property that is called row. So we could add another property. So now we could directly using the property and assign the parsed argument string. So this row is coming from the parameters argument of the constructor, and this uppercase row is this constructor. So we don't have a private field row because we don't need it, right? Not all the time you have to have the private field. And we discussed previously, you could directly just have a property if that's all you need. So that's, for example, what we have here. And also for this, it's the same problem. It's complaining because when we don't write out the base, specifically the base class constructor, it implies that we are inheriting the base class. You still inheriting the base class, but inheriting the base class constructor that does not take 0 parameters. So if, for example, I come back to here and write out a constructor that takes a 0 parameter, then you will see that now it's happy, right? So because it's implied that inheriting that. But in fact, for example, I want still to inherit from the base class that takes 1 parameter. Okay, so if you recall, previously we talked about constructor reload, meaning that, for example, I could reuse the constructor within this class. So for example, if I don't want to use the base class, I could say this email, for example. So what happened here is instead of using a base refers to the base class that is a person class. I'm using this. This refers to, as you see when I highlight this employee constructor above is highlighted. So I'm in fact referring to the constructor within this class. So I'm reusing some of the code that within this class. So base and this is different. In terms of how the constructor is executed, we can use an example. Let's say we have an employee class. So we create an employee object, and using one of the constructor, I want to show you how the execution of the constructor is done. First, as you see that I'm invoking this constructor takes only the employee name. So I'm right here on this. This is the matching constructor. However, you see that the highlighted part is in fact the one that after this colon. So basically, I'm going to use this constructor first. So this constructor is in fact this constructor, the one that on top. However, when you come to this constructor, I'm going to execute the base class constructor first. The base class constructor is going to lead you to this person class with the matching parameters. I'm going to execute all the lines there. So I return back to this base class, inheritance base class. Then I come back inside this employee class and execute the lines inside this here. Then I get out. I'm back to here. So the sequence of the constructor execution is start with whatever after this colon. So for the employee with the parameter of name, I'm going to execute this constructor, so which is this employee constructor. But for this constructor, employee with taking 4 parameters, first I'm going to execute base class. So the key here is base class constructor is executed first before the derived class constructor. So now I'm back right here. This, in fact, is illustrated in the slide as well. So, for example, you have some base class and derived class. When you inheriting from the base class and using base class constructor, it's going to execute the base class constructor first, then continue with the derived class constructor. Okay, so now, for example, if this E1, as you see that it's an employee class, it in fact has already inherited all the properties, the public members, for example, name, role, age, from the base class. We didn't write those code in the employee class. All of those are inherited from the person class. So for the employee class, for example, we want to add some new information. Not only we are employee is a person, but also adding new information extends beyond the base class. So for example, if I want to calculate the years to retirement, so I add a method, for example. Okay. This is a method. I'm going to return, for example, 70 is the retirement age, and then subtract your current age. As you see that I have access to the age property in the derived class because I'm inheriting those. So again, derived class inherit everything from the base class, but only you can use only based on the access level. For example, age is public, so that I can access that in the class outside of the person class. However, if the lowercase h, that is a private member of the person class, base class, even though I inherited them, I still cannot access them. Then you might ask, what do you mean by you inherited but you cannot access it? As you see, we cannot access it. But for example, we are in fact using these informations. Okay, so that's what I meant. Okay. So this is, as you know previously, if I don't write any method access modifier, this is by default a private member of the class. So for example, if I come out of that class, I want to say E1 dot calculate year to retirement, I don't have access to that. So in fact, I want to keep that as a private member, and I want to instead create a property called years to retirement. For this, I only want that to be a read-only member. So I only keep the getter part. I would say that the year to retire is, I'm going to call this calculate year to retirement method. So because this is a public member, so if I come back here and I say E1 dot years to retirement, it's there. Okay. So let's say, for example, we're going to use a different, let's say 30 years old and it's a staff. So we can access all the public members from the base class. And for example, I want to say, okay. All right, so current age is 30 and 70 subtract 30, the years to retirement is 40 years. Okay, so that's correct. Next, I want to talk about if I want to continue build this inheritance hierarchy. For example, if I have a manager class, and this time the manager class is the derived class of the employee class. Again, I could have a manager constructor and let that inherit from the base class. Okay, for example, let's see, we want this name. And base class, we want to use the one that has name, gender, age, but the role instead, this time I'm going to initialize with manager. I don't have to input anything within my constructor. Okay. So as you see that from person to employee, we add some new information such as the calculate year to retirement, a method, private method, and we also added a new years to retirement. So let's say that this employee, this manager is of course an employee, but it has a different retirement age. Will be 5 years shorter than the regular employee. So how can we write that, for example? Let's say, if for instance, if I'm just going to copy that employee class information into the manager, and that is allowed. So instead of, I'm gonna remove another 5 years from the, so basically, or direct say 65 is the retirement age, and can I use this? So let's give it a try. Of course, it's not a good practice, first of all. I'm gonna duplicate some of the code. But another point is it doesn't even work. So let's say we have a manager now. And again, it's the same age, same gender as the employee class object. I'm going to add a new line. So this time I want to display what the manager object does. So as you see that I added a new method, okay? Not exactly add a new method because it has the same name as the employee class calculate year to retirement, but a different implementation. So we want to see if that works. Same like not, right? So Sarah is a manager. It has the same age of 30. So based on our rule, it should be 65 minus 30. Should be 35, but I still get 40. Right? So there's a problem here. The problem coming from this years to retirement. Year to retirement is a property right here. And within this property, So both the employee and the manager class using this property. They both calling this calculate year to retirement. But there are two calculate year to retirement. So by default, this calculate year to retirement is going to call this calculate years to retirement within its own class, closest. So the question here is, what if I want to modify existing members of from the derived class? Right? We already mentioned that we can add new members. That's not a problem. What if I want to modify? So now we want to introduce another keyword that's called the virtual. Virtual means that you can use my implementation if you like, or you can have your own implementation if you want to. So the red wiggle line here is basically tells you that the virtual cannot be private. So if you don't write anything, by default it's private, so that's why it's complaining. So now you have some options. Of course, it's okay to make it public. Okay. However, what if I do not want to expose that method? Do I have other options? So another option would be protected. Right? What it means is, if it's public, that means it's wide open. I can come here and write, for example, M1 calculate years to retirement if the X modifier is public. If you don't want that, you want something in between. You have this protected. Protected means that this is available within the current class, and also it's available in the derived class, but nothing else. So if I mark this as protected, then when I go to the main window, if for example I want to say m1.calculate, or I say e1.calculate, I don't have that. I can't access it. The reason I cannot access it, because in this we are in the main window class that is not inherited from the employee class. Therefore, you cannot have access to this. However, in the manager class, it's a different story, because in the derived class, you can access, if it's protected, you can access in the derived class. So now we want this to be protected in, so it's still available in the derived class. And we are going to use a keyword called override. So override is the imperative of the virtual. So virtual, as I mentioned earlier, means that you can use my current implementation in the base class, or you can make modifications. So if you want to make modifications, you mark it as override. So now if I come back to the, if I rebuild this, Sarah's retirement is in fact 35. So meaning that when I calling this years to retirement, and this calls the calculate retirement method, I realize there are two different implementations based on whether you are an employee or you're a manager. And they can tell that by using this virtual and override pair. So virtual override basically is provide a method for you to make modifications on the base class existing members. Okay, so for now that's what we want to discuss about inheritance.